Hello everyone, I'm Ruth. Today we are going to talk about SAT geometry questions. Here's a question set. You can find it by clicking the link below. For question 1, we can see line L and line M are parallel to each other, and the line N intersects both. So angle C and angle E are alternate interior angles, and angle A and angle C, angle E and angle G are vertical angles. So the conclusion is angle A equals angle C equals angle E equals angle G. So let's see the answers. The correct answer is A, because as we said, the four angles are all equal. As two of them are add up together on both sides, the equation should work. So answer A is correct. Let's see question 2. In question 2, a circle is inscribed in a square, and we need to find the remaining area. First, we can calculate the area of the square and the area of the circle, and subtract one by another. To calculate the area of a square is to square its side, which in this question is 1. So 1 squared, 1 times 1 equals 1. And to find the area of a circle, the equation is pi r squared, which r is radius. In this case, it's half of the side of the square, so it's 0.5. So the equation would be 0.5 squared times pi, which almost equal to 0.8. The last step is easy. 1 minus 0.8 equals 0.2. So the answer is A, 0.2. For question 3, we need to draw a diagram by ourselves. Here's the diagram. We can use the same method as we used in question 2. This time, we'll find out the area of the large rectangle and minus the smaller rectangle. As we can see from this diagram, the size of the smaller rectangle is 15 and 20. The walk path is 3 yards wide, so if we add 3 yards to both sides, then make the large rectangle have sides 21 and 26 yards wide. So if we calculate it, it will be 21 times 26 minus 15 times 20, which equals 246. Answer B is correct. Here comes question 4. There's a three-dimensional diagram, and we can see it is a cylinder inscribed in a sphere. And in the front view, we can see it's a rectangle inscribed in a circle. Because it asks us about the volume of the cylinder, which is pi r squared times height. If we see the front view, it will be more easy to find the height. We can use Pythagorean theory to solve a triangle. The cylinder has a base radius 3 and the sphere has a radius 5. So if we see the little triangle here, the other side will be 4. Because 3, 4, 5 is a typical ratio for right triangles. But notice, it's only half of the height of the rectangle and the cylinder if we see the three-dimensional diagram. So the real height should be 8. 2 times 4 equals 8. Now we can calculate the volume, which equals pi times 3 squared times 8 equals 72 pi. So the right answer is A. Question 5. A cube inscribed in a sphere, as we can see in this diagram. Then the longest segment between 2 points in a cube is touching the sphere. So where are these 2 points? In the diagram we can see it is, in this case, the lower left front point and the right upper point in the back. So we connect those 2 points with a dash line, as we can see here. Since it is the longest segment in the diagram, we know that it is the diameter of the sphere, which equals 2 radii. But how can we find the side of this cube? We can solve a right triangle inside the cube. One point is at the center of the cube or the sphere. We draw a line perpendicular down to the bottom surface of the cube, which is also the center of the square. And we connect the center of the square to the vertex, and here comes a right triangle. Then we need to solve it. The segment between the center of the cube and the vertical should also be the radius, which is 3 square root 3 over 2. Since we are going to find the side of the cube, we assume it is A. So the segment between the center of the cube and the center of the bottom surface is half of the side, which is A over 2. And finally, the last one, between the center of the bottom surface and the vertical, which is square root 2 times A. So now we can solve the triangle by Pythagorean theory. A over 2 squared plus root 2 times A over 2 squared equals 3 root 3 over 2 squared. And we solve the equation, and we have A equals 3, which is answer D is correct. For question 6, we can again use the equation for volume of a cylinder, which is V equals pi r squared times h, base times height. And we substitute all the value in, which equals 55 equals pi times 3 squared times h. And h equals 2 meters. The answer is B. Here comes question 7. First, let's read the question together, because there are some key words in this question. The length of the side of cube water tank is 10 meters. It currently holds 4 meters deep of water, 4 meters. If an iron triangular prism with a base area of 5 square meters and the height of 4 meters, again 4 meters, is thrown into a water tank, then how much the height of the water will increase? Now we know that the height of the prism thrown in the water is 4 meters high, and the water in the tank is already 4 meters deep. So the water will totally submerge the prism. And the prism is made of iron. Though it is not a physics question, the prism will not float on the water. It will be at the bottom of the water. Then we know that the water increased equals the volume of the prism. So first we can solve the volume of the prism, which is 5 times 4, base times height equals 20. And how much higher will increase in the water tank? Well, it is the same thing. This time, the height of the water increased equals volume of the prism, which is also the volume of water increased, divided by the base, which in this case is a square. So 20 divided by 10 times 10 equals 0.2. Answer A is correct. Question 8. In the question, we know two sides of a triangle and try to find the largest area if we can build a triangle. As we can see here, the largest triangle should be the red one when the two sides are perpendicular. In other case, as we see, if the side with a length of 8 as a base, the height perpendicular to it will be less than 5. The largest height is 5 when the sides are perpendicular. So the area equals 5 times 8 over 2 equals 20. The answer is C. Question 9. To solve this problem, we need to find out the area of the large rectangle and minus the three small triangles. It says the perimeter of the rectangle is 80, which is the sum of the four sides, or 2 times the sum of length and width. And we know AB is 3 times of BC. If we assume BC equals x, we can solve x equals 10. Then AB equals 30. In the exam, we can directly mark those numbers on the paper. We can use the same way to solve other segments. So the final equation is 30 times 10 minus 20 times 5 over 2 times 10 times 10 over 2 times 30 times 5 over 2. We solve it equals 125. Answer D. In question 10, we can use the same method we used in question 9. As we know the perimeter is 48, we can solve the two sides of the rectangle, which BC equals 8 and AB equals 16. And E is a midpoint, so EC equals half of 16 equals 8. And we can calculate the area of the triangle then. It is CE as a base and ED as a height. So CE times AD over 2 equals 8 times 8 over 2 equals 32. The answer is D. Let's go to question 11. Because this time it is drawn on the coordinate, it will be easier if we complete a rectangle around the triangle and use the rectangle to minus the area of the 3 little triangles to solve the big triangle. It will be pretty easy. You can even come to the grid one by one to solve this problem. So the 3 little triangle has areas of 1 and 1 and 1.5. And the large rectangle has an area of 6. 2 times 3 equals 6. So if we use 6 minus 1 minus 1.5 minus 1, it will equal 2.5. The answer is B. Question 12 looks pretty complicated. It is a square inscribed in a circle, inscribed in a larger square. And we need to compare the area of these two squares. But the key point to solve this question is the radius of the circle is constant. We can assume it's R. And we can use this R to solve these two squares. The area of the larger one, ABCD, equals side times side, which equals 2R times 2R equals 4R squared. In the smaller square, R equals half of its diagonal. And we can see this square as two isosceles right triangles come together. One of the triangle has the area of 2R times R over 2. So two of them add up to 2R squared. So if we compare ABCD to HIJK is 2 to 1, the answer is A. Question 13. The polygon ABCDE is made by equilateral triangle and a square, so we know that each side is equal. It is an equilateral pentagon. The perimeter of the pentagon is 30, so we know each side equals 6. Then we can calculate the area of the square and the triangle and add them up. The area of the square equals 6 times 6 equals 36. Because it is an equilateral triangle, it has 60, 60, 60 angles. If we draw a height, it becomes a 30, 60 right triangle. If we know the ratio, we can easily get 3, 3, square root 3, and 6. If we certainly forgot, we can use Pythagorean's series to solve it, so don't worry about it. So here we got the height 3 root 3. So the area equals 6 times 3 root 3 over 2 equals 9 root 3. The answer should be B, 36 plus 9 root 3. Okay, question 14. It is the last question of the question set. And it is actually not that difficult as it looked like. We all know how to calculate the volume of a rectangular. It is length times width times height. So when it comes to ratio, it is the same thing. We just need to times them all together. The equation would be 1.25 squared times 0.9 equals 1.406. The question asks for the value increased by, so we just need to subtract 1 from 1.4. It is 0.4. The correct answer is B, 40%. Yeah, so that's it. We finished this question set. And you can find the PDF form from the link below. If you have any other questions, please leave your comments. Maybe we'll discuss them next time.